Irreducible fractions. Chapter 8. Let's review. Let's review divisibility rules. So what is a divisibility rule? It is a way used to determine whether an integer is divisible by a divisor without performing division. So, how to know whether a number is divisible by 2? Simply, we should look at the end of the number. It should have 0, 2, 4, 6, or 8. So, examples. The first number, 56,389. Is it divisible by 2? No, because it's ending with a 9. 946. Is it divisible by 2? Yes, because it's ending with a 6. Now, to know whether a number is divisible by 5, the number should be ending with 0 or 5. And to know whether a number is divisible by 10, the number should be ending with a 0. Let's take some examples. So the first number, it's ending with a 5, so it's divisible by 5 but not divisible by 10. The second number is not divisible by 5 because it's ending with a 9, and not divisible by 10 because it's also ending with a 9. Now, the last example is divisible by 5 because it's ending with a 0, and it's divisible by 10 because it's ending with a 0. Now, how to know whether a number is divisible by 3? I should be adding the digits. So the sum of digits should be a multiple of 3. To know whether a number is divisible by 9, so I should be adding digits. They should have a multiple of 9. Example. So over here, as you can see, this is the first number, 2,175. What I'm going to do, I'm going to add the digits. 2 plus 1 plus 7 plus 5. The answer is 15. Is 15 a multiple of 3? Yes, because 3 times 5 is 15, so it's divisible by 3. Is it divisible by 9? No. Now, the second example, again, what I'm going to do, I'm going to add digits. So 9 plus 0 plus 1 plus 8. The answer is 18. So, is 18 a multiple of 3? Yes, because 3 times 6 is 18. Is it a multiple of 9? Yes, because 2 times 9 is 18. So both numbers are divisors of this number. Now, how to know whether a number is divisible by 4? So the last two digits should be a multiple of 4. Let's take some examples. So the first one, 640. It's ending with a what? It's ending with 40. So 4 times what gives me 40? 4 times 10. So the number is divisible by 4. Another example. So 726. So 26. 4 times what gives me 26? We don't have. So the number is not divisible by 4. Another example. 912. 4 times what gives me 12? 4 times 3. So the number is divisible by 4. Now, natural numbers. So natural numbers are of two types. They are either prime numbers or they are composite numbers. What do you mean by prime numbers? The prime numbers, they have factors as 1 and themselves, while composite numbers, they have many factors. Examples of prime numbers. So, the number 2 is a prime number having 1 and 2 as factors. What do you mean by that? So if I have 1 times 2 equals 2, so the factors of 2 are 1 and 2 only. That's why the number 2 is a prime number. Let's take another example. So the number 5 is a prime number having 1 and 5 as factors. What do you mean by that? We have 1 times 5 equals to 5. So the factors of 5 are 1 and 5. That's why 5 is a prime number. Now, composite numbers. Examples. The number 8 is a composite number having 1, 2, 4, and 8 as factors. So 1 times 8 is 8. So the factors of 8 over here are 1 and 8. What else gives me 8? So we have 2 times 4, have a product of 8. So 2 is also a factor of 8, and 4 is also a factor of 8. That's why the number 8 is a composite number. Another example. So we have the number 20 is a composite number having 1, 2, 4, 5, and 10 as factors. What do you mean by that? We have 1 times 20 gives me 20, so 1 is a factor and 20 is a factor. And we have 2 times 10 is 20, so 2 is a factor and 10 is a factor. We also have 4 times 5 is 20, so 4 is a factor and 5 is a factor. So that's why 20 is a composite number having all of these as factors. Now fractions. This is a fraction? Yes. Now, is this a fraction? No. Is this a fraction? Yes. Is this a fraction? No. Is this a fraction? Yes. So, in fractions, we're having two numbers. The number that's above, we call it a numerator, and the number that's below, we're going to call it a denominator. Simplifying fractions. Whenever you see simplify, it means we have to divide. Let's start with the first fraction, 12 over 18. These two numbers, they remind you of which they are multiples of which number. Let's see, this is ending with a 2 and this is ending with an 8. So I can divide by what? I can divide by 2. So the fraction is going to become 6 over 9. Can I simplify more? Can I divide more? Yes. Divide by what? Divide the numerator and denominator by 3. So 6 divided by 3, it's 2, and 9 divided by 3, it's 3. Now, the fractions, the numbers in the first fraction, they are composite numbers. So in the first fraction, as you can see over here, we have composite numbers. In the second fraction, we also have composite numbers. Now in the last fraction, we have prime numbers. The first fraction that you can see over here, this fraction, which has composite numbers, we're going to call it irreducible fraction. Again, the second fraction over here, which is 6 over 9, having composite numbers, we're going to call it also reducible fraction. Now, whereas this fraction having prime numbers, where I cannot simplify it anymore or divide it anymore, we're going to call it irreducible fraction. So we have reducible fractions and we have irreducible fractions. So this is reducible, this is irreducible. Again, we are still in simplifying fractions. We have 40 over 80. As you can see here, 40 over 80, this is ending with a 0, this is ending with a 0. This means I can divide by 10. So divide by 10, divide by 10, the answer is 4 over 8. Can I simplify it more? Can I divide it more? Yes, I can. Divide by what? We can divide by 4, divide by 4. The answer is going to be 1 out of 2. So this is a reducible fraction. I could simplify it. This is a reducible fraction. I can simplify it. This is an irreducible fraction because I cannot simplify it anymore. So this is reducible. This is irreducible. Another example. So 32 over 40. These numbers, they remind you of which multiplication table? They remind you of the multiples of 4. So divide by 4, divide by 4, we're having a fraction 8 out of 10. Can we simplify more? Yes, we can. Divide by which number? We can divide by 2. So divide by 2, divide by 2, the answer is going to be 4 out of 5. So the first fraction is reducible, The second fraction is reducible because we could simplify it, and the third one is irreducible. So we have reducible and we have irreducible. Again, the last example, as you can see, 150 over 300. This is divisible by what? This is ending with a 0, ending with a 0. We can either divide by 5 or by 10. I'm going to divide by 10. Divide by 10, divide by 10. The answer is going to be 15 out of 30. And can we simplify it more? Yes, we divide numerator and denominator by 5. By 5, we're ending up with 3 out of 6. Can we simplify more? Can we divide more? Yes, because we can divide the 3 and the 6 by 3. So divide by 3, divide by 3, I'm ending up with 1 out of 2. Can we divide more? Can we simplify more? No, we cannot. So this one that we reduce, we're going to call it reducible fraction. Again, this one that we simplified, we're going to call it reducible fraction. Again, this is a reducible fraction, we can simplify it more. And the last one that we cannot simplify it, we're going to call it irreducible fraction. So we have reducible fraction and we have irreducible fraction. So reducible fraction or irreducible fraction, let's try to think together. So 80 over 90, is it reducible? Yes, I can divide above and below the numerator and denominator by 10. So this is reducible fraction. How about this one, 1 out of 10? Can we simplify it more? Can we divide more? Can we simplify over here? Can we divide the numerator or denominator by a certain number? No, we have a prime number over here and we have a composite over number over here, but we cannot simplify them by any number. So that's why this is an irreducible fraction. How about this one? This fraction. This fraction over here, 72 ends with a 2, 108 ends with an 8. This means I can simplify by 2. So this is a reducible fraction. Now let's take this number, 11 out of 13. Over here I have two prime numbers. So 11 is a prime number, 13 is a prime number. I cannot simplify it, I cannot reduce it. That's why it's an irreducible fraction. Again, over here, this number ends with a 2, and this number ends with a 5, and this number ends with a 0. So this can be simplified by 5. So this is a reducible fraction. Now over here, can we simplify it? Over here, no, we cannot, because we have two consecutive numbers. So 45, 46, we cannot simplify it. Another example, over here we also have two consecutive numbers. We have 20, 21. We also cannot simplify it, we cannot reduce it. Again, we have 56 and we have 57. Can we simplify it? No, we cannot. That's why these fractions are irreducible fractions. So we have reducible fractions and irreducible fractions.